In this video, we're going to talk about how to multiply radicals. So remember, we used the product property when we were simplifying radicals. So we can use the product property to multiply radicals of the same index. When multiplying, it can be helpful to first simplify the numerical part of the radicands and then completely simplify the product after multiplying, if it's possible. So for example, if we're trying to multiply the square root of 20 times the square root of 27. So both of these radicands are just numerical, so let's go ahead and see if we can simplify. Well, the square root of 20, I can rewrite that as the square root of 4 times the square root of 5. The square root of 4 is 2, so this is 2 times the square root of 5. The square root of 27 I can rewrite as the square root of 9 times the square root of 3. The square root of 9 is 3, so that's going to be 3 times the square root of 3. So now I want to multiply these two together. So I have 2 times the square root of 5 times 3 times the square root of 3. Well, what I'm going to do is I'm going to first pull out the coefficients. So I have 2 times 3. And then remember, the product property tells us that we can put the part under the radicands together. So since the radicals have the same index, I'm just going to write this as the square root of 5 times 3. So 2 times 3 gives me 6, and the square root of 5 times 3 is the square root of 15. So 6 times the square root of 15 is my answer. So when we're multiplying radicals, you're going to start off by simplifying the numerical part of each radical if possible. Then multiply the terms outside the radical and multiply the radicals using the product property, which remember we can use as long as the radicals have the same index. And then we're going to simplify the product if possible. So let's try this example. So first what I'm going to do is I'm going to take each radical and look at it separately, and I'm just going to look at the numerical part and see if I can simplify that. So for example, 15, I want to see if there's any squares I can divide out of 15. And there aren't, so I'm just going to leave that one alone. But if I look at 45, well, I can factor actually a square root of 9 out of there, right? So the square root of 9 times the square root of 5 is equal to 45, so I'm just going to leave that 5 in there with that x to the 4th. So 2 times the square root of 9, that's going to be 2 times 3, and then we have the square root of 5x to the 4th. So we have 6 times the square root of 5x to the 4th. So you may be wondering why I didn't go ahead and simplify that x to the 4th. Because if you simplify the variables before you multiply, sometimes you end up simplifying twice. So that's why I just simplify with the numerical part first, and then I'll fully simplify the product after I multiply. So let me show you what that looks like. So now I'm going to take these two and multiply them together. So I have the square root of 15x cubed times 6 times the square root of 5x to the 4th. So 6 is the only coefficient that I have, so I'm going to pull that out, and then I have the square root of 15x cubed times 5x to the 4th. Well, look at what's going on the inside here. These are just basically two monomials that are getting multiplied together, right? So remember, when we work with monomials, we work with the coefficients, and then we have to use exponent properties on the variables. So it's going to be square root of 15 times 5, and then I have x cubed times x to the 4th. So we have 6 times the square root, well, 15 times 5 is 75, and then x cubed times x to the 4th, remember I add those exponents when I'm multiplying and I get x to the 7th. So now let's look at how to simplify this final product, right? Because we want to make sure all our radicals are fully simplified. Well, the square root of 75 I can rewrite as the square root of 25 times the square root of 3, okay? And then we have the square root of x to the 7th. Well, we have now 6 times the square root of 25 is 5, and then we have the square root of 3. When we look at the x to the 7th, since we're talking about a square root, we want to see what's the largest even number less than 7 that we can factor out. So we can write this as the square root of x to the 6th times the square root of x to the 1, right? Because 6 plus 1 is equal to 7. So now let's just do some more simplification. So 6 times 5 is going to be 30. So we have 30 square root of 3. The square root of x to the 6th, well, when I do that square root, I'm going to take half the exponent. So that's going to become x cubed. And then I still have that square root of x. So now let's pull out the terms that are outside the radicals. So we have 30x cubed. And then we have the square root. Well, what's still under the square root is 3 and x. So what I did is I wrote all my steps from this problem, and I just kind of, explained what I did in these steps, okay? So this is the same problem that I just showed you, but I just wrote out everything. So remember, first what we did is we simplified that numerical part on the second radical. So I got to the point where I did the square root of 15x cubed times 6 times the square root of 5x to the fourth. I just wanted to remind you that what I did was, multiply coefficients and use the product property of radicals. Here we use those multiplying monomial strategies we talked about. Here we use the product property of exponents, and that's how I got that x to the seventh. And then these are all my simplification steps. So now let's try multiplying these two radicals together. So remember, first I'm going to simplify just the numerical parts because I'm going to end up simplifying everything anyway once I have my final answer. So let's look at these. Okay, so square root of 12, the biggest perfect square I can divide out of 12, remember, is 4. So I have the square root of 4, and then I have the square root of 3x squared y. The square root of 4 is 2, so I have 2 times the square root of 3x squared y. Now let's go to the second radical. Well, let's look at 24, and let's figure out what the biggest perfect square that divides 24 is. Once again, it's going to be 4, so I have the square root of 4 times the square root of 6x cubed y to the fifth. The square root of 4 is 2, and then I have the square root of 6x cubed y to the fifth. So now let's multiply these two radicals together. So I have 2 times the square root of 3x squared y times 2 times the square root of 6x cubed y to the fifth. So let's first pull out the coefficients. So we have 2 times 2, and then we have everything under the square root that's being multiplied. So we have 3x squared y times 6x cubed y to the fifth. Okay, so now let's use those strategies we had for multiplying monomials inside the root. So outside I have 2 times 2, which is 4. And then this I'm going to rearrange. I'm going to write this as like 3 times 6. And then I'm going to do x squared times x cubed. And then I have y times y to the fifth. So that y, remember, has an exponent of 1. Okay, so now I'm just going to continue with my simplification. So I have 4. 3 times 6 is 18. And then remember, whenever I'm multiplying terms with exponents, I add them together if they have the same base. So that's going to be x to the fifth. Y to the 1 times y to the fifth is going to be y to the sixth. So now I have to simplify my radical that I have here. So I have 4, and then let's look at the square root of 18, and the square root of x to the fifth, and the square root of y to the sixth. Okay, so we have 4. The square root of 18 is the square root of 9 times the square root of 2. So that is going to simplify to 4 times the square root of 9 is 3, and then I have the square root of 2. Now let's look at the x to the fifth. The biggest perfect square I can factor out is going to be x to the fourth. So that's going to be x to the fourth times x to the 1. The square root of x to the fourth, I just take half the exponent and I have x squared. So it's going to be x squared times the square root of x. And now I have y to the sixth. Well, since 6 is divisible by 2, that's going to be y cubed, right? I just do 6 divided by 2 because that's the index of our root, and so I get y cubed. So my y cubed is my last term. Okay, so now let's combine everything. Well, 4 times 3 gives me 12. And then the other terms I have on the outside are x squared and y cubed. And then I have the square root, and then everything under the square root is going to be 2 and x. So this is my fully simplified answer. So now you can go ahead and pause the video and try doing this example on your own. So remember, I started off simplifying the numerical parts of whatever radicals I could, and I could only do that on the first one because I could factor out a square root of 4. So that turned this into 12 times the square root of 2x cubed y to the fifth. So I multiplied that by the second radical, so I pulled out the coefficients, which gave me a 48 in front. And then inside the radical, I combined the coefficients, which gave me 4. X cubed times x gave me x to the fourth. Y to the fifth times y cubed gave me y to the eighth. So then I took the square root of 4, so that's 2. The square root of x to the fourth is x squared, and the square root of y to the eighth is y to the fourth. So it actually works out in this problem that all of your terms are on the outside, and we don't need a radical in our final answer. So now let's try this problem. So this is working with cube roots, but even though it's a cube root, the idea is still the same. So we're going to still simplify whatever we can. So if I look at 12, is there a cube root that I can divide out of 12? No. And then 18 doesn't have a cube that I can divide out either. So I'm just going to leave these as is, and I'm going to go ahead and multiply. So when I multiply, remember I put the coefficients together. So I have 5 times 3, and then I have the cube root of negative 12xy to the fourth times 18x squared y squared. So 5 times 3 gives me 15. And then I have the cube root of negative 12 times 18. And then I have x, which is basically x to the 1 times x squared. And then I have y to the 4th times y squared. Okay, so now let's work on simplifying this. So we have 15 times the cube root of negative 12 times 18 is negative 216. X to the 1 times x squared, I'm going to add the exponents and get x cubed. Y to the 4th times y squared, I add the exponents and get y to the 6th. Okay, so now let's take apart all of these terms. So we have 15 times the cube root of negative 216 times the cube root of x cubed and the cube root of y to the 6th. Okay, so we have 15, and then the cube root of negative 216 is negative 6. The cube root of x cubed, well, 3 divided by 3 is 1, so that's just going to be x. And then the cube root of y to the 6th, 6 divided by 3 is 2, so we have y squared. So 15 times negative 6 is going to be negative 90, and then we have x, y squared. Okay, so this actually works out where we have no radical in our final answer. So now you can go ahead and pause the video and try doing this example on your own. So if we look at these numerical portions, there's no power of 4 that we can factor out of each of these terms. So we're just going to go ahead and multiply. So we have 2 times 3, which is 6, and then we have the 4th root of 8x cubed y squared times 2x to the 5th y squared. So we put together the 8 times 2, which gives us 16. X cubed times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. Then we separate these out, so the 4th root of 16, the 4th root of x to the 8th, and the 4th root of y to the 4th. So the 4th root of 16 is 2. 8 divided by 4 gives me x squared. Y to the 4th, so I just do 4 divided by 4, which is 1, so I'm just going to write that as y. 6 times 2 is 12, and then I have x squared and then y. So remember, you can multiply radicals that have the same index using the product property of radicals. It can be helpful to simplify the numerical part of each radical first and then simplify the entire product after multiplying using the product property.